This is section R.6, rational expressions. In mathematics, the word rational means fraction. Remember, just like rational numbers were fractions, rational expressions are going to be fractional expressions. So this section deals with fractional expressions. Now this is more than just like a fraction, 1/2 or 2/3. We're going to have some variables involved. So remember that the integers are fractions with the denominators of 1. The same thing applies with rational expressions. If you do not see a denominator, it is understood to be 1. Whatever rules and procedures developed for fractions must still work if we have nothing but integers. Otherwise, that says that there is something peculiar about fractions, and there really isn't anything peculiar about fractions. So multiplying, dividing, and simplifying rational expressions. When working with fractions, multiplying, dividing, and simplifying is actually easier than adding and subtracting. So multiplying, dividing, and simplifying rational expressions all involve the same basic procedure. We never tell you this procedure up front, but this is what it is. Factor and cancel. So this is another application of factoring. Now, since most of these things are rigged, if after you do your factoring, if you cannot get at least one pair of factors to cancel, then something is wrong. Something is supposed to cancel in almost all of the cases. So multiplying rational expressions. The method for multiplying rational expressions. Excuse me. Step 1, multiply the numerators. Step 2, multiply the denominators. Now, of course, those two steps can be reversed, or they can be done, quote, at the same time. And then step 3, reduce. Always reduce your fractions. Okay, always, always, always reduce your fractions. In actual practice, we cancel before we start to multiply. You may cancel as long as one expression is in a numerator and the other expression is in a denominator. Canceling is reducing first rather than last. So if you don't cancel, or if there's something that could have canceled but you don't see it, if you do step 3, your fraction will still be reduced. If you do all of your canceling first, then your fraction will also be reduced. Before you can cancel, all plus and minus signs must be in parentheses except for possibly a leading minus sign. This amounts to factor before you cancel. Factoring also means that all your plus and minus signs are inside parentheses except for possibly a leading minus sign. Some examples. We're going to perform the negative operations and simplify. I've got x squared plus x minus 12 over x squared plus 2x minus 8 times x squared plus x minus 6 over x squared minus 2x minus 3. Again, don't actually multiply. The idea is to factor everything in sight and then start canceling. So this is the factorization of each one of those two original rational expressions. So this is an application of our factoring. We have x plus 4 times x minus 3 over x plus 4 times x minus 2 times x plus 3 times x minus 2 over x minus 3 times x plus 1. Okay, now the idea is to start canceling. So I can see the x plus 4s canceling, I can see the x minus 3s canceling, and the x minus 2s canceling. So there's all the canceling that can take place. So after we have canceled everything in sight, the only thing that's left in the numerator is x plus 3, and the denominator is just x plus 1. So our final answer is x plus 3 over x plus 1. Notice we never actually did multiply. Even though the operation was multiplication, we never actually did multiply. All we did was factor and cancel. Second example. I've got x squared minus 2x over x squared minus x minus 6 times x squared minus 2x minus 3 over x cubed minus 2x squared. Okay, again, the idea is not to really multiply, but to factor everything in sight. Okay, from the first numerator I can factor out an x, leaving me x minus 2. First denominator factors as x minus 3, x plus 2. Second numerator factors as x minus 3, x plus 1. And the second denominator I can factor out an x squared, leaving me x minus 2. So there is my factoring. Okay, now again, after you've factored, start canceling. Okay, I can see the x minus 3's canceling. I can see x minus 2's canceling. And this x will cancel with one of those x's. So I'll be able to mark out the 2 and be left with a 1. So there's all my canceling. Again, this should be marking out the 2. So in my numerator, I'm left with x plus 1. My denominator, if I write it in correct order, I'll have x times x plus 2. Now, if you wish to distribute the x in the denominator and have x squared plus 2x, that's entirely your choice. Personally, after I do all the factoring, I really don't feel compelled to do the multiplication. There actually is a reason why we don't multiply stuff out after we have it factored. That reason will become apparent later on. So again, if you want to multiply out the denominator, your choice. Example number 3. I have a plus b over a squared minus b squared times a cubed minus b cubed. Okay, the a cubed minus b cubed is really over 1. So that's going to be the first thing I'm going to do. I'm going to write it as over 1. That way everybody looks like a fraction. Now we're getting ready to factor. Okay, a plus b is factored, but I will enclose it in parentheses, so that way all my plus and minus signs will be inside parentheses. That denominator is a difference of squares. It's a plus b, a minus b. The difference of cubes, remember that's a minus b times a squared plus ab plus b squared. And then we look for any sort of canceling that we can do after we do the factoring. Okay, you may have to look up again how to factor sums and differences of cubes. The a plus b's cancel. The a minus b's cancel. That leaves us a squared plus ab plus b squared all over 1. Now remember, we don't normally write denominators of 1 in our final answer. It's okay to do it in your work, but it's not okay in your final answer. So our final answer is just a squared plus ab plus b squared. And there's nothing else you can do with it. Okay, let's move on to dividing rational expressions. Okay, if you remember from your days of grammar school, to divide fractions, you invert the second fraction, so you're actually finding the reciprocal of it, so you invert the second fraction, then multiply. Okay, this is where you actually do any factoring and canceling. Okay, so after you've inverted and started to multiply, you factor and cancel. And then step 3, of course, reduce. Always reduce your fractions in your final answers. Okay, always, always, always. So some examples: perform the indicated operations and simplify. Now sometimes the rationals will just say simplify. So our first one, we have x squared minus 3x minus 10 over x squared plus 2x minus 15 divided by x plus 2 over x squared plus x minus 12. Remember, we're supposed to invert the second fraction and multiply, so here I've inverted the second fraction, multiply. Okay, that's the times sign, not an x. After we invert the second fraction, start to multiply. Remember, don't really multiply. Factor everything in sight. So let's see, this numerator will factor as x minus 5, x plus 2. This denominator factors as x plus 5, x minus 3. This denominator is factored, so I'll just put parentheses around it. And this numerator factors as x plus 4 times x minus 3. So I've factored everything in sight. Now we want to start canceling. Okay, the x plus 2's can cancel. The x minus 3's can cancel. And I believe that's about it. So there's our canceling. In the numerator, we're left with x minus 5 times x plus 4. Our denominator is just x plus 5. Okay, you can leave it like that if you wish, or if you're really feeling ambitious, you can go ahead and FOIL out the numerator. It is your choice. Again, my preference is not to multiply stuff out after I do all the factoring. Again, there is a reason for it. The reason will become apparent later on. But if you want to do the FOIL, that's your choice. You'd have what? X squared minus x minus 20 if you FOILed it out. Doing the extra step of FOILing it out, you actually do run the risk of possibly making an error. So that's another reason not to do it. Number 2, I've got x squared minus x minus 6 over x minus 4 divided by x squared minus 9. Remember, this x squared minus 9 is over 1. So we'll do that first. I've written it as over 1. That way everybody looks like a fraction. Now in order to divide, remember, invert the second fraction and multiply. So we're going to invert the x squared minus 9 over 1 as 1 over x squared minus 9. So we've inverted. Now we're getting ready to multiply. Remember, that really means factor everything. Okay, x minus 4 is factored, so I'll just put it in parentheses. This numerator factors as x minus 3 times x plus 2. This denominator is a difference of squares, so it's x minus 3, x plus 3. So there I factored everything in sight. And now we get ready to cancel. It looks like the only thing that's going to cancel is the x minus 3's. Okay, numerator, we're left with x plus 2. The denominator is x minus 4 times x plus 3. Okay, again, don't write in the numerator times 1, because 1 times anything is the anything, the identity property. Okay, now again, if you want to FOIL out the denominator, if you want to do x minus 4 times x plus 3 to get x squared minus x minus 12, it is your choice. Again, personally, I don't like to do it. There is a reason why we don't multiply stuff out after we have it factored. That reason is not apparent now, but it will become obvious later on. Example example number 3. I've got x squared minus 3x minus 4 divided by x squared minus 16 over x plus 1. And again, this numerator is over 1, so that'll be the first thing we do. We'll go ahead and write it over 1. That way everybody looks like a fraction. Okay, again, remember to multiply, invert the second fraction and multiply. So I'll invert that to be x plus 1 over x squared minus 16. First fraction stays the same. Now we want to multiply everything. We want to factor everything. So this factors as x minus 4, x plus 1. Okay, x plus 1 is factored. We just put it in parentheses. And x squared minus 16 is x minus 4, x plus 4. So everything is now factored for us. Now we start canceling. The only canceling that I can see is x minus 4. Okay, the x plus 1 are both in the numerator, so that's why they don't cancel. Remember, one must be in the numerator, one must be in the denominator. So in the numerator we're left with x plus 1 times x plus 1, or really x plus 1 squared. Our denominator is x plus 4. If you want to square this out or FOIL out x plus 1 times x plus 1, it's your choice. Again, I prefer not to. If you FOIL it out, you'll have x squared plus 2x plus 1 all over x plus 4. Again, it's your choice. Again, to take the extra step to do the foiling, you run the risk of possibly making a careless error. That's why it's best not to do it. Again, there are really good mathematical reasons why we don't do it, just that those reasons are not obvious yet. Remember, we still are just in the first chapter. Now let's look at simplifying rational expressions. In some sense, we've already been doing it. Multiplying and dividing, the directions are sometimes just replaced with the word simplify. So simplifying rational expressions really amounts to factoring and canceling. Okay, that's really what we should tell you, just factor and cancel, but we actually just use the word simplify. So keep in mind that whenever you are supposed to multiply, divide, and or simplify rational expressions, it all comes down to factor and cancel. Now with multiplying and dividing, you needed 2 rational expressions to work with. With simplify, you can just work with 1. Like, simplify the fraction 3/6, it reduces to 1/2. So with division, remember you must invert the second fraction and then multiply. But remember, multiply means factor and cancel. So the decision to multiply out the factors after you've done all the canceling is entirely up to you. Again, I prefer not to do it. Later on you will see the reasons why we don't do it in mathematics. So some examples. Simplify each of the following. So these are just going to be one fraction. So you're going to really reduce it. So I've got x squared minus y squared over x cubed minus y cubed. You're going to remember, you cannot cancel until you have factored, which means all plus and minus sign inside parentheses. These are outside parentheses. So we factor. I got a difference of squares, a difference of cubes. Remember, the squares factors is x minus y, x plus y. The cube is going to factor as x minus y times x squared plus xy plus y squared. So we've factored everything in sight. Again, you may want to review your factoring techniques. After we have it factored, the x minus y's cancel. So we're going to be left with x plus y in the numerator and x squared plus xy plus y squared in the denominator. And there is your simplified answer. Personally, I don't think the simplified answer looks any better than the original problem, though. Number 2, we've got x squared minus 5x plus 6 over x to the 4th minus 13x squared plus 36. Okay, again, the idea, factor. Okay, factor before you cancel. So the numerator will factor as x minus 6x plus 1. Okay, the denominator, because of the x squared, it's going to factor as x squared minus 9, x squared minus 4. Remember, multiply to be 36, add to be negative 13. We have difference of squares, another difference of squares, so we can factor some more. Okay, x squared minus 9 is x minus 3x plus 3. X squared minus 4 is x minus 2x plus 2. So now we have it completely factored. Now the x minus 3's will cancel, the x minus 2's will cancel. So now we do our canceling. So again, the x minus 3's and the x minus 2's. Our numerator, everything canceled, so we're left with 1. Our denominator is x plus 3, x plus 2. Now again, if you want to multiply out the denominator, that's fine. You'll have x squared plus 5x plus 6. But that's entirely up to you. Addition and subtraction of rational expressions. Okay, this is what makes working with fractions so horrible, is adding and subtracting them. So in order to add or subtract rational expressions, we must have a common denominator. Okay, now any common denominator will do. So typically we use the lowest or least common denominator, abbreviated LCD, but any common denominator will work. Okay, now some of the problems that you may see for homework will make you find the lowest common multiple. Okay, that's as if you were going to add or subtract the denominators, but your first step is actually find the lowest common multiple, which is called the LCM. Now there actually are some mathematical situations in which you are looking for lowest common multiple, but you're not working with fractions. Fortunately for us, we don't deal with those in this class. So if you don't use the LCD, you're guaranteed extra work in reducing the fraction. So remember, any common denominator will work, but if you don't use the lowest, you will have extra work guaranteed in order to reduce the fraction. Now, just because you have used the LCD doesn't mean that there won't be extra work to reduce the fraction. It's just that it's not guaranteed anymore. So there are three cases to look at when adding and subtracting rational expressions. So we're going to take a look at each of the three cases, going from the easiest to the worst case scenario. So all denominators are equal. This is the nice case. This is what you hope happens, and it will happen. Okay, you will have problems like that. Just see if you can deal with them. So notice that the integers are a special case of this. Remember, the integers all have denominators of 1, and when all the denominators are equal, we really don't pay attention to the denominators. So the method for adding or subtracting rational expressions when all denominators are equal. So this is your procedure. Step 1, add or subtract the numerators. Again, be very careful with the signs. The usual thing that goes wrong is failure to distribute a minus sign. Step 2, keep the original denominator that all the fractions had. Okay? Remember, that's what's making it a fraction, is having that denominator, so don't lose it. Step 3, reduce, which remember, reduce means factor and cancel. Now, unlike multiplying and dividing, you cannot cancel before you do the addition and subtraction. So some examples. Excuse me. Perform the indicated operations and simplify. Here's our first one. I've got 3x plus y over 2x minus 7y, minus 2x minus 3y over 2x minus 7y, plus 3x over 2x minus 7y. Okay, all the fractions have a denominator of 2x minus 7y. So we're going to keep that denominator. So all of our denominators are equal, so we're in the easiest case. Okay, I'm going to keep track of the denominator of 2x minus 7y. We will add or subtract the numerators. In doing so, we will keep each separate numerator in its own set of parentheses. Hopefully this will remind us to distribute minus sign as we go along. So I put each one of these separate numerators in their own little set of parentheses, even the lonely old 3x. Okay, now remember, this minus sign is that minus sign right there. This plus sign is that one, and there I've kept my denominator. Okay, so again, I've written one big fraction, putting each individual numerator in its own set of parentheses. I'm now getting ready to drop the parentheses, which means I have to distribute that minus sign. So I'll end up with 3x plus y minus 2x plus 3y. Remember, minus is plus, and then plus 3x, still all over 2x minus 7y. So we're going to drop the parentheses, and remember to distribute the minus signs. Okay, after we drop the parentheses, we're now getting ready to combine similar terms. So I can combine my x terms, combine my y terms in the numerator. Leave the denominator alone. Okay? In general, when you're adding, subtracting, or working with fractions at all, there is no reason to change the denominator unless you're factoring and canceling or finding a lowest common denominator. So once you get a common denominator, which we already had to start with, there is no reason to change it unless you factor and cancel. So combine similar terms in the numerator. So I'm going to combine what's in red and what's in kind of that pink looking color. So combining the x's, 3x minus 2x is x, plus 3x is 4x. The y's, y plus 3y is 4y. So I got 4x plus 4y over 2x minus 7y. Now if you notice in the numerator, I could factor out a 4, but if I factor out the 4, nothing cancels. So there really is no reason to do it. I'm just going to leave it alone like that. So if the factoring doesn't lead any canceling, you don't have to do it. But if you go to all the trouble to factor, and then you notice that nothing cancels, I wouldn't undo it. Okay, so if you can tell before that the factoring won't cancel, just leave it alone. So again, factoring out the 4 doesn't lead any canceling, just leave it as is. Our second example. We've got 3x plus 5 over 2x minus 1, plus x minus 6 over 2x minus 1, minus 6x minus 7 over 2x minus 1. Okay, again, they all have the same denominator. They all have the common denominator of 2x minus 1. So I'm going to write each individual numerator in parentheses, so that way I'll remember to distribute the minus sign. So again, enclose each separate numerator in its own set of parentheses. So there's the 3x plus 5 in parentheses, plus x minus 6 in parentheses, minus 6x minus 7 in parentheses, all over the common denominator, Please don't lose the denominator. If you lose the denominator and just write down the numerator as the answer, you're going to get it wrong. Remember, it is a fraction. Okay, now we're getting ready to drop the parentheses, which means I must distribute that minus sign. So when I distribute this minus sign, I'm going to end up with minus 6x plus 7 for that term. So I'm going to have 3x plus 5 plus x minus 6 minus 6x minus 6x plus 7 all over 2x plus 1. Excuse me, 2x minus 1. So after we drop the parentheses, and remember to distribute our minus signs, we're now getting ready to combine similar terms in the numerator. So combine similar terms in the numerator. So combine the x terms, combine the constant terms. So combine what's in red, combine what's in black in the numerator. So the x's, 3x plus x is 4x, 4x minus 6x minus 2x. And the constant, 5 minus 6 is negative 1, and negative 1 plus 7 is 6. So I've got negative 2x plus 6 all over 2x minus 1. Okay, the 2x's cannot cancel because I have plus and minus signs outside parentheses, namely those two guys. Okay, if you want to factor out 2 or negative 2 from the numerator, you can, but nothing cancels. Okay, now again remember, these 2x's cannot cancel because I did not factor. I have plus and minus signs outside parentheses. Denominators are opposites or additive inverses of each other. Now, if we were dealing with nothing but numbers, this case wouldn't happen. It's only with variables that this happens. So denominators are opposites or additive inverses of each other. So recall, the opposite or additive inverse of an expression is found by changing its sign. You know, the opposite of 5 is negative 5. Opposite of x is negative x. So the opposite of x minus 2 is the negative of x minus 2, which if I distribute the minus sign, I get negative x plus 2, or if we rewrite it, I get 2 minus x. We sometimes don't like to start with a minus sign. Notice this 2 minus x is out of order from what we like. We like to have the variables first. This is why it is important that you get used to writing things in correct order so that we can recognize when something is not in correct order. So notice that if we have x plus 2 and 2 plus x, then there's not a problem since they are equal. Remember the commutative property for addition. It is only when the sign in the middle is a minus sign that we have a problem. You know, x minus 2 versus 2 minus x. For simplicity, we're going to assume that we are looking at just two rational expressions. Okay, that is just going to make it easier for the moment. That we only have two rational expressions. So clues, you have denominators that are opposites. Excuse me. Number 1, the denominators are binomials with the terms separated by minus signs. Given with plus signs is no big deal. Number 2, one of the denominators is, quote, out of order. That is, not in alphabetical order, like y minus x instead of x minus y, or has 2 minus x instead of x minus 2. Remember, we like to have the variable terms before constant terms and polynomials, and we also like alphabetical order. For those that don't do that, this might be a problem for you. Remember, we like things to be in order. Numbers will come after variables when we write the terms of the polynomial. As coefficients, the coefficients come first, but we like x plus 2 instead of 2 plus x. We like x minus 2 instead of 2 minus x. We like alphabetical order. So there are the clues that you have it. How do we fix the problem? Step 1. Put the denominator that is out of order in order. So for example, if it has 2 minus x, you will change it to x minus 2. So what that means is you have actually factored out a negative. You factored out negative 1. So that means we have to do something with that negative 1. So step 2, change the sign in front of this fraction. So what you've really done is put the negative you factored out of the denominator in front of the fraction. So that's what you really did. You factored out the minus sign from the denominator and you put it in front of the fraction. You should now have two fractions with the same denominator. Again, we're taking the point of view that you just have two rational expressions. Now, why does this work? Okay, we're using the fact that a fraction has three signs. The sign of the numerator, the sign of the denominator, and the sign of the fraction. Okay, the sign of the fraction is actually what's in front of the fraction. Here's the fact. You can change any two of them without changing the value of the fraction. So it's kind of like you can factor out a minus sign and then put that minus sign someplace else. So what we're doing is we're changing the sign of the denominator and the sign in front of the fraction. That's what we're really doing. Let's try some examples. So again, we have changed the sign of the denominator and the sign of the fraction. Okay, that's what we really did. Now let's try some examples. Perform the integrated operations and simplify. Again, let's go back and pick on that x minus 2 and 2 minus x business. So I've got 3x plus 4 over x minus 2 plus 2x minus 7 over 2 minus x. It's like the denominators are almost alike. So this is the one that's out of order. Remember, when we write a polynomial, we want to have the variable terms before the constant term. So, excuse me, the second denominator is out of order. So 2 minus x is out of order. So we will put it in order. We're just going to write it as x minus 2. Now remember, we factored out that minus 1. So that minus 1, we will change the sign in front of the fraction. So the minus that we factored out here, we'll change that to a plus. Excuse me, change that to a minus. So we will show those changes in red. So remember, this is becoming x minus 2. That plus is becoming a minus. Okay, so there it is. We now have the same denominator, namely x minus 2. So we're back to what we were just doing before. So I'm going to write one fraction, something over x minus 2, and then in parentheses 3x plus 4 minus, in parentheses, 2x minus 7. So we can now combine the fractions. So again, I've rewritten this same problem but without the color. And there we've done our parentheses around each individual numerator. Again, don't lose the denominator. Okay, we're now getting ready to drop the parentheses. So that'll become 3x plus 4 minus 2x plus 7. Remember, minus is plus. So this is where we left off on the previous slide. Here I've dropped my parentheses. We're now getting ready to combine similar terms in the numerator. So when I combine the x's, 3x minus 2x is x. When I combine the constants, 4 plus 7 is 11. So I have x plus 11 all over x minus 2. So let's take a look at another one. I've got 3x plus y over 3y minus 2x plus x minus 7y over 2x minus 3y. Again, the numbers look very much alike, but one of them is out of order. Remember, we like alphabetical order. X comes before y, so it's the first denominator that is out of order. So in this problem, the first fraction has its denominator out of order. So we put the first denominator in order. So there, we've changed 3y minus 2x to 2x minus 3y. And now remember, we have to change the sign in front of the fraction. Since you don't see a sign, it's actually a plus. So now, change the sign in front of the first fraction. There's the minus sign that we factored from the denominator. So now our denominators are the same, namely 2x minus 3y. So put it in order, change the sign in front of the fraction. Okay, let's get rid of the color. So we're getting ready to combine the fractions. So here it is without the color. Now, each individual numerator inside parentheses, this minus sign was that minus sign right there. We're now getting ready to drop the parentheses. So I'll have minus 3x minus y plus x minus 7y all over 2x minus 3y. So again, this was the last line from the previous slide. Here's where we have dropped the parentheses in the numerator. We now combine similar terms in the numerator. For the x's, minus 3x plus x is minus 2x. And for the y's, minus y minus 7y is minus 8y. Notice if you factor out minus 2 from the numerator, nothing will cancel. Now again, remember, these two x's cannot cancel because I have these minus signs outside parentheses. Remember, if you didn't factor, chances are you can't cancel. If you have plus or minus signs outside parentheses, except for possibly a leading minus sign, you cannot cancel. A leading minus sign would actually be a minus sign in front of the fraction, which we don't have. So factoring out 2 or negative 2 doesn't lead to any canceling, so I just leave it alone. Okay, now let's take a look at the worst case scenario. Not all denominators are equal. Okay, this is the worst thing that can happen to us with fractions. We must get a common denominator. Typically we find the lowest or least common denominator, abbreviated the LCD. The LCD becomes the new denominator for all of the fractions. This then puts us back in the case of all denominators are equal. Okay, now notice that the denominators being opposite was actually a special situation of not all denominators are equal. So we have to figure out, how do you find the LCD? Remember, if all you're doing is finding the LCD but not adding subtracting fractions, it's the LCM. You're finding the lowest common multiple. So the method for finding the LCD. Step 1, factor all denominators completely. So all the denominators, just start factoring like crazy. Now, if you make a mistake factoring, it doesn't matter what you do next. You've already missed the problem. Step 2, the LCD will equal the product of all the different factors from step 1. Now, do not actually multiply out the factors. Just indicate the multiplication. For example, write x plus 2 times x plus 3 rather than x squared plus 5x plus 6. The reason is that we will need factors in order to simplify later. Remember, simplify means factor and cancel. So again, the LCD is the product of the different factors from step 1. Now, what if you have factors that are common to the different denominators? For repeated factor, the LCD uses the one with the largest exponent. So, for example, if one denominator has a factor of x plus 1 squared and another denominator has x plus 1 cubed, the largest exponent would be the cube. So the LCD would use x plus 1 cubed. So remember, the LCD uses the largest exponent for a repeated factor. Now, if you list a factor more than it's needed, you will actually have a common denominator, not the lowest, but a common. So this is how you find the LCD. Now, if you've gone to all the trouble to find it, what do you do with it? So, using the LCD. The LCD becomes a new denominator for all the fractions. Okay, so it's like all of your old fractions will be written as something over the lowest common denominator. We must adjust or fix the numerator. So how do we adjust or fix them? For each fraction in the original problem, okay, so for each of the fractions in the original problem, this is what you're going to do. Multiply, and this time we really mean multiply. Multiply the original numerator by factors from the LCD that do not appear in the original denominator. So here we actually mean multiply, not just indicating multiplication. So that might involve distributing or FOIL. Okay, so again, multiply each of the original numerators by factors from the LCD that do not appear in that fraction's original denominator. Let's try some examples. So perform the indicated operations and simplify. Here's our first one. I've got 2x plus 3 over x minus 4 minus x plus 3 over x minus 2. Okay, our denominators are different. One of them is x minus 4, the other one is x minus 2. So the denominators are already factored, so we can now find the LCD. Remember, the LCD is the product of the different factors from the denominators. So I see x minus 4, I see x minus 2. That is my LCD. Again, don't multiply that out. I know you know how, it's just FOIL. Just leave it like that. So that is our LCD. Now we're getting ready to use the LCD. So we use the LCD as the new denominator for each fraction. So we're going to need to fix the numerators. So remember, multiply each fraction by factors from the LCD that are not in its denominator. This guy misses x minus 2. This one misses x minus 4. I've shown those things in red. Notice they do have the same denominators though now. X minus 4 times x minus 2. Don't cancel. Remember, in the numerator, you must literally multiply them out. So again, remember, we multiplied each numerator by factors from the LCD that were not in its original denominator. So this one missed x minus 2. That's why I have it. This one missed x minus 4. And there it is. Okay, now let's FOIL out the numerators. Don't FOIL out the denominators. Remember, in order to simplify, you must factor and cancel, and our denominators are already factored. So we're going to FOIL out the numerators. So from the first one, I get 2x squared minus x minus 6. The second one becomes x squared minus x minus 12. Again, keep the denominator, x minus 4, x minus 2. Okay, we're going to now write each individual numerator in its own set of parentheses. So we're now getting ready to combine the fractions. So again, this is where we left off. Here is each individual numerator in its own set of parentheses. We keep our denominator the same. I've dropped the parentheses. This becomes minus x squared plus x plus 12. Okay, as time goes on, we may be able to do this, going from this step to this step in our heads. Let's see, now we combine similar terms. So I've got my different colors here. Let's see, for the x squares, 2x squared minus x squared is just x squared. For the x's, minus x plus x is 0, so there's no x term. And for the constant, minus 6 plus 12 is plus 6. So I have x squared plus 6 in the numerator, x minus 4, x minus 2 in the denominator. Okay, nothing cancels. I'll leave it alone. Now again, if you really, truly want to multiply out the denominators, you can, but there's nothing to be gained from doing that. I would just leave it alone. Number 2, I have 2 over x squared minus x minus 2, minus 4 over x squared plus 4x plus 3, plus 3 over x squared plus x minus 6. Okay, all the denominators are equal. I need to factor each one of these denominators. So the first one factored is x minus 2x plus 1. The middle denominator factored is x plus 3, x plus 1. And the last denominator factors is x minus 2, x plus 3. So I've factored all my denominators. We're now getting ready to get the LCD. Remember, the LCD consists of all the different factors from the denominators that I see. I see x minus 2. I see x plus 1. I see x plus 3. There's x plus 1 again. I don't need it again. There's x minus 2 again. I don't need it again. And there's x plus 3 again. I don't need it again. My LCD is just x minus 2, x plus 1, x plus 3. So there's my LCD, x minus 2, x plus 1, x plus 3. Don't multiply it out. Okay, we're now getting ready to fix the numerators. Okay, remember, multiply each numerator by factors from the LCD that do not appear in its denominator. In the first fraction, x plus 3 does not appear in its denominator, so I'll have 2 times x plus 3. The middle fraction, x minus 2 does not appear in its denominator, so I'll have 4 times x minus 2. And for the last one, x plus 1 does not appear in its denominator, so I'll do 3 times x plus 1. So again, I've shown those in red. Again, remember, multiply each numerator by factors from the LCD that do not appear in its denominator. Now notice, all the denominators are equal. I'm going to have to do some distributing in the numerators eventually. So there I've combined it into one fraction. I have my minus sign here for that minus sign. This plus sign is that plus sign. I'm now getting ready to distribute in the numerator. So I'm getting ready to drop the parentheses in the numerator. Now again, leave the denominator alone. Also, don't forget to write it. So when I distribute in the numerator, I'll have 2x plus 6 minus 4x plus 8. Again, minus is plus 3x plus 3. Okay? So I've dropped the parentheses in the numerator. We're now getting ready to combine similar terms in the numerator. So again, this will be my first slide on the next slide. So I put them in color. When I combine the x's, 2x minus 4x is minus 2x, plus 3x gives me just x. The constant, 6 plus 8 is 14, plus 3 is 17. My numerator is x plus 17. My denominator stays the same. Don't multiply out the denominator. It's not worth the extra step and possibly getting it wrong. Let's take a look at another one. Number 3. I have 3 over x plus 2 minus x over 2 minus x minus x squared minus 3x plus 1 all over x squared minus 4. Okay, in this problem, the middle denominator is out of order. So I'm going to write it as x minus 2 and change that minus sign to a plus sign that's in front of it. So there I went from the original problem to putting the middle denominator in order, and I factored the last denominator. Okay, x squared minus 4 is the difference of squares. So I've done everything that I need to do to figure out my common denominator. Remember, the LCD consists of all the different factors from the denominators that we see. I see x plus 2, I see x minus 2, and there they are again. So I don't need to repeat them. So my LCD is x plus 2 times x minus 2. Okay, we're now getting ready to fix the numerators. Remember, multiply each numerator by factors from the LCD that are not in its denominator. This first fraction misses x minus 2, so I'll do 3 times x minus 2. The middle one misses x plus 2, so I'll have x times x plus 2. The last denominator is the LCD, so I leave its numerator alone. Technically, I'm multiplying it by 1. Okay? So there, I've shown those in red. Again, the first fraction didn't have x minus 2 in its denominator. The middle fraction did not have x plus 2. The last denominator was okay. So now when I write this as one nice big fraction, I keep my denominator of x plus 2, x minus 2. It looks like I'm going to need to distribute in the numerator. So when I distribute in the numerator, I'll have 3x minus 6 plus x squared plus 2x. Then distributing the minus sign, minus x squared plus 3x minus 1. all over x plus 2 times x minus 2. So we've dropped our parentheses in the numerator. We're now getting ready to combine similar terms in the numerator. So let's see, when I combine my similar terms, working with the x squares, x squared minus x squared is 0. Okay, the constant, 3x plus 2x is 5x, plus 3x gives me 8x. Excuse me, that's the x term. Now my constant, negative 6 minus 1 is negative 7. So I have 8x minus 7 over x plus 2x minus 2. Now again, if you want to work out the denominator, that's what you get. Again, it's better to leave it alone once you get it factored. You went to all the trouble to factor, may as well leave it alone. And again, there are mathematical reasons why we do not multiply out the denominator. The numerator, excuse me, the numerator we do because suppose you multiplied it all out and combined similar terms and it equals 0. Then your simplified answer would in fact be 0. Okay, let's move on to the final topic of this section with rational expressions. Complex fractions. Okay, complex fractions. First, exactly what are they? So definition, a complex fraction is a fraction in which the numerator or denominator or both contain a fraction. So kind of loosely speaking, it's a fraction over a fraction. The fractions that we have worked with so far are called simple fractions. Okay, not simplified, but simple. Some notes about this. Number one, a simple fraction is not necessarily simplified. For example, 3/6. It's a simple fraction, but it's not simplified. 3/6 simplifies to 1/2. A complex fraction is never considered simplified. So what that means is you can never write a complex fraction as your final answer. Now, oddly enough, in science classes, we sometimes do write complex fractions as final answers. But for us, we don't do it. Number three, since decimals are another form of fractions, like 0.3 is 3/10, a fraction containing decimals is also not considered simplified. So if you write something like 0.3 over 0.7, that's not simplified. So here's an example of a complex fraction. I've got 2/3 plus 1/4 all over 5/6 minus 1/2. Now because it is all numbers, a calculator could actually simplify it for us. And I may actually show you how to do that. So hopefully looking at this, you're thinking, God, that looks horrible. Who would ever write something like that as a final answer? But you'd be surprised. So the method for simplifying a complex fraction. Okay, now going back to this complex fraction, there are actually 1, 2, 3, 4. There are actually 5 denominators, but there are 4 simple denominators. Now there are actually a couple of ways to simplify a complex fraction. I'm going to show you the method that most students prefer, even though it's something they don't always understand, but it is what they prefer, oddly enough. Excuse me. Step 1. Find the LCD of all the simple fractions of the complex fraction. Excuse me. Remember, that amounts to factoring your denominators. Step 2. Multiply each simple fraction of the complex fraction by the LCD from step 1. Remember, this still amounts to multiply each numerator of each simple fraction by factors from the LCD that do not appear in the simple fraction denominator. Now again, we really do mean multiply here. Actually do multiply. So you may have to distribute, you may have to do FOIL. Step 3. You should now have a simple fraction. Simplify it. Okay. Now, what will this involve when you try to simplify the simple fraction? Multiply out terms and or do FOIL. Combining similar terms. And, of course, factoring and canceling. Let's try some examples. Simplify each complex fraction. Okay, the first one, we've got that number. I'm going to go ahead and show you that on a calculator. So this is the calculator you can actually download for free from the internet. Let me turn it on. Okay. So, open parenthesis for the numerator. I've got 2 divided by 3 plus 1 divided by 4. Close parenthesis for the numerator. Divided by, open a parenthesis for the denominator. 5 divided by 6 minus 1 divided by 2. close the denominator parentheses. Okay, now remember, any time the numerator or denominator contain any sort of operation, they must be enclosed in their own set of parentheses in your calculator. Now, what does this work out to be? So we get this rather nasty looking decimal, or at least not too nasty. To make it into a fraction, do math, and then the first choice says change your answer to a fraction. So press enter twice. Enter, enter. It gives us 11/4. Okay, so we should be expecting 11/4 from our work by hand here. So let's get back to our work by hand. Okay, if I look at my simple fractions, 3, 4, 6, and 2, I need a common denominator for 3, 4, 6, and 2. It's 12. So my LCD is 12. So I'm going to multiply each one of these individual simple fractions by 12, or if I write it as a fraction, 12 over 1. So I'll show that in red. So there I am multiplying each one of the 4 simple fractions by 12 over 1. If I do the canceling, see 3 goes into 12 4 times, 4 goes into 12 3 times, 6 goes into 12 twice, and 2 goes into 12 6 times. So there's all my cancel. Okay, now when I do the canceling and start my multiplication, I have 4 times 2 is 8, plus 1 times 3, 3. So I'll have 8 plus 3. My denominator, 2 times 5 is 10, minus, okay, 1 times 6 is 6. So, again, this is where we left off from the previous slide. So I start doing my multiplication. 8 plus 3. Then 10 minus 6. Okay, now don't leave it like that. Do the arithmetic. 8 plus 3 is 11. 10 minus 6 is 4. I get 11/4, just like the calculator gave. Okay, now when it's all numbers, you sometimes lose what's really going on because of the numbers. And it's all numbers. You may as well give it to your calculator. Let's try something with variables. So number 2, I have 1 over x squared minus 1 over y squared, all over 1 over x cubed minus 1 over y cubed. So I get my LCD. Okay, now it certainly involves x and y. Now remember, the LCD takes the largest exponent. So I'm going to have an x cubed, y cubed. So I'm going to multiply everybody by x cubed, y cubed. Technically, x cubed, y cubed over 1. So I've shown that in red. So when I start doing my canceling, x squared goes into x cubed x times, y squared goes into y cubed y times, and downstairs the x cubes cancel, and in the second one, the y cubes cancel. So there's my canceling. So I'm going to be left with xy cubed minus x cubed y over y cubed minus x cubed. Now notice it reversed alphabetical order, but it did it all by itself. I didn't force it to happen. It happened all by itself. Again, it still amounted to multiply each numerator by factors from the LCD that are not in its denominator. So it's like this guy misses an x and a y cubed. This one misses an x cubed and a y. This one missed the y cubed. This one missed the x cubed. My denominator is a difference of cubes. I can factor it. My numerator, I can factor out an xy. So when I factor out xy, I'm left with y squared minus x squared. Here's my difference of cubes, y minus x, y squared plus yx plus x squared. I still have a difference of squares in the numerator. The numerator will factor some more. This will factor as y minus x, y plus x. So let's take the extra factoring step. We now have everybody factored. I can now cancel. My denominator has y minus x, my numerator has y minus x, so they cancel. That's all that's going to cancel, the y minus x's. I'm left with xy times y plus x over y squared plus yx plus x squared. If you feel compelled to distribute the xy, that's up to you. I went to all the trouble to factor. I don't feel compelled to do it. Okay, let's take a look at another one. I have 3 over x plus 1 minus 3 over x minus 1 all over 5 over x squared minus 1. Okay, let's get the phone to stop ringing. See, this denominator, x squared minus 1, difference of squares. It factors as x plus 1, x minus 1. So there, I've factored it. So my LCD is going to be x plus 1, x minus 1. Remember, it's the product of the different factors from each denominator. We're now getting ready to fix the numerators. So remember, multiply each numerator by factors from the LCD that are not in its denominator. Another way of looking at it is I'm multiplying those 3 simple fractions by x plus 1, x minus 1 all over 1. from the first one, the x plus 1's cancel. The second one in the numerator, the x minus 1's cancel. And in the denominator, they both cancel. So in the numerator, I'll be left with, after I do the canceling, I'll be left with 3 times x minus 1 minus 3 times x plus 1, and my denominator is just 5. Okay, we now have to distribute in the numerator. So I'll have 3x minus 3 minus 3x minus 3 all over 5. Now again, this was the last line, the last line from the previous slide. So 3x minus 3 minus 3x minus 3. And now combine terms. 3x minus 3x is 0. Minus 3 is minus 6. So the answer is negative 6/5. Let's take a look at one more. I've got 1 over x plus h minus 1 over x all over h. Remember, this denominator is really h over 1. So my LCD, each one of these denominators is factored. X plus h is factored, x is factored. My LCD is x times x plus h. So I'm going to multiply each one of these 3 individual fractions by x times x plus h, technically over 1. Now, I didn't write this one over 1 because that guy is technically over 1 as well. Okay, let's do some canceling. X plus h is cancel. X is cancel. Okay, nothing cancels. In my numerator, I'll have x times 1 is x. So x minus x plus h. My denominator, I'll just leave it as hx times x plus h. Again, don't multiply this out. It's factored. You're going to need factors in order to cancel. So again, the numerator, x times 1 was x minus x plus h. Okay, drop the parentheses. So I'll have x minus h all over hx times x plus h. Combine similar terms in the numerator. X minus x is 0, so I'm left with minus h in the numerator. So I have minus h over hx plus x plus h. This is now actually a leading minus sign. There are no other terms in the numerator. That's why it gets to be a leading minus sign. This minus sign is allowed to be outside parentheses. So I can, in fact, cancel the h's. This is the first time I think we've ever had a leading minus sign. Again, it's a leading minus sign because there are no other terms in the numerator. So when the h's cancel, I'm left with negative 1 over x times x plus h. So the h's are canceling, and there's your final answer. There is no need to distribute the x. Please don't do it. If you take more math, you'll discover why it's not done. That is the end of section R.6.